Salutations. This is similar to example 2 in the book. We're going to do another division. This one is called polynomial division, polynomial long division. We'll see that the shortcut is shorter. But we'll see that in the next example. Okay, so let's start. I'm going to start by first writing here my dividend or denominator. And then here I'm going to write my numerator dividend divisor. So 3x cubed plus 17x squared. Again, I'm keeping track while I'm doing this. I'm keeping track. This is third degree, second degree, first degree. So I want to make sure that if there's any one that I'm skipping, I need to leave a gap for it or write a 0. So this is step up, setting it up. And actually, I'm going to leave some more space up there. Okay, step 2. I'll write here in case this is helpful for someone. First we divide, then we multiply, then we change the sign, then we add, and then if you want to add the last step would be drop, or you can drop that step, whatever works for you. But the first step is divide, and we always look only at the first term for division. So for division, we're going to check this, and we're going to see how many times does x go into 3x cubed. Again, that's the same as imagining this division. So we're breaking this big division into all these small division problems. This is a way to do this would be to first think of the number and then think of the variable. And I do that even here, even if I'm not writing that down, I still do the same thing. So I do, this is going to be a 3, and then in terms of variable, it's going to be x squared. Okay, that's step 1. Step 2, we multiply. What do we multiply? We multiply what we just got. We multiply this by our whole denominator. So by that whole polynomial. In this case, it's going to require 2 different multiplications. So we're going to do 3x squared times x. So that's going to be 3x cubed. And then 3x squared plus times 3. So there's going to be plus 9x squared. So that's step 2. Step 3 is changing the sign. So that means that I'm going to make that a minus, and I'm going to make that also a negative sign. So both of them are negatives in this case. So we can now add. That's step 4, add. So this disappears. I check that it does. It should always disappear, otherwise I'm doing something wrong. But don't just, if for whatever reason this wasn't a 3, don't just scratch it without looking at it. I've seen people do that before. This is a checking point. Okay, and here we get an 8x squared, and I imagine we're going to need to drop this one, step 5, and I will start all over again. So we start from the beginning. We're going to do division first. So how many times does x go into 8x squared? And that's going to be 8x times. And now we multiply. So we multiply this number that we just got, that number times that whole thing. So it's going to be 2 different multiplications. It's going to be 8x times x is 8x squared. And then it's going to be 8x times 3 is going to be plus 24x. Again, actually, if you remember, you could not put the positive signs here. Only put the negatives. And then the next step is easier. If you remember to just leave it blank, now when you're doing the change of signs, if it's blank, you just make it a negative. And if it's a negative, you just cross it vertically and make it positive. Okay, so, and now we add, and again, this disappears. We check that that's the case. And here we get negative 3x minus 11. And then we have to do this whole process once more. So how many times does x go into negative 3x? Well, negative 3 times. We multiply this negative 3 times that polynomial. So negative is going to be negative 3x minus 9. Then we change the sign of everything, and we add. And that those 2 steps are like subtracting, but I think it's easier to do it in 2 parts. We add, and in this case, this disappears as it should, and we get a negative 2. And now x plus 3 cannot go into negative 2 anymore, so that's our remainder. By the way, it took me a year of teaching math in this country for a student to let me know the difference between remainder and reminder. I think for the whole year was saying reminder, and no one reminded me of the difference. So if I say reminder instead of remainder, please remind me. Okay. Anyway, let's finish this problem. So lastly, we still have to take care of that. So our answer, if you want to write it up here, our answer is going to be this, and you can write this minus 2 over, but when there's more things here, you might make a mistake. So what I strongly recommend is that you always make this a plus. And then leave the sign with whatever number is there. In this case, it wouldn't matter much, but so it's, that's my recommendation. Always make it a plus and keep the negative sign with the remainder. And then lastly, super important to write this. This and this are the same, but if you don't write that, your answer is wrong. So that is the part that we couldn't divide. How can I explain that differently? So imagine, imagine we have a pizza and there's 5 people. There's four slices, 4 big slices of pizza for 5 people. No, sorry, for 3 people. Let's imagine this is for 3 people. So each of us gets 1 slice. And then this one still needs to be divided. So it's going to be 1 and 1/3. So what we're doing here is this is the remainder, and this is what we're dividing by. So it's the same idea. It's what you can divide easily, you divide, and then what you couldn't divide, you leave it still to be divided. That's what that means, okay? So just to be really clear, the answer here would be this. This is the result of doing that division, the whole thing. Okay? Thanks for watching, and I'll see you in the next video, learning synthetic division.